thanks for coming by, because I guess data is not the main and most important topic on this conference, and mostly not for the most of your software engineers as well. So I'm happy about everyone who shows up, and then maybe, although this talk is called Can Data and ML Learn from Software Engineering, I also give the message that maybe software engineering can learn a little bit from data. Because can data and ML really learn from software engineering? We can answer this now, and the answer is yes. And probably they should as well, not only can. We'll go a little bit more into deep there. When I'm doing these talks, I usually ask the audience, just to get a feeling, who is mostly related to software engineering, software architecture from you? Okay. And who is more into data engineering or data science? Okay, so software engineering and a little bit more people. I expected this. Okay, so who am I? I'm Matthias. I'm working as a data engineer, architect, consultant, whatever, but having a software engineering background for a company called Codecentric. We are doing consulting stuff in Germany, building software and software engineering house, and doing this also with a company called Product Duck, which we're doing nearshoring, but that's it for the advertisement part. So I said we are doing software and data, but 80% of our projects are mostly software. And we come across some quotes. So for instance, I once had a customer, and the software team just said, I don't want to have to do anything with data that feels like Mordor over there. And there's also quotes like, data professionals need to utilize software engineering best practices. This is from Mark Freeman, one guy that does a lot of stuff about data engineering these days. But also on the other side, hey, data and software engineering, data is not software engineering, and teams that don't respect it won't have success in analytics and AI, and everybody wants to have success in AI these days. So, what is correct? No. And last but not least, there's this feeling and this opinion in a lot of places that data engineering is quite rough around the edges, and it's simply because data engineers don't do the stuff that software engineers do, what makes everything better. And on the other way, for software engineers, data is often like this. We still have these UI tools where we click through and build ETL pipelines or model stuff somewhere, and then it gets automatically generated somewhere. Or maybe not that, from a software engineering perspective, wild, but still concerning, using notebooks, Jupyter notebooks, working in them, and you think there's a lot of people thinking about you can't actually build something in notebooks. It can be done. The question is, should it be done? But why is it even a question? Why do we talk about data at this conference here? So data is becoming an elementary part of every product these days. It's not like, okay, you store data. Of course, most databases have a database, but data is used today. It's integrated in in applications. You can do reporting in your applications. You use the data to build ML predictions that get integrated into your application. So you always have something to do with data. Their users and clients want to analyze their data. They want to do, for instance, do self-service BI based on their data, which you have probably in your SaaS application. So it's getting one. Software isn't isolated. It's not like we have the software thing, and then the other thing, there's some data warehouse, and you put all the data into the data warehouse, and you don't care anymore. But it gets one, by the way. And I already did a talk in 2020, which was how much software engineering does a data scientist need to know? The main thing was each data scientist can actually code, but most of them can't software engineer. And I don't expect them to be software engineer. I mean, they didn't learn it. They learned all the statistical and mathematical stuff instead, which we as a software engineer was most likely the highest hurdle in the first years of university, all the mathematics stuff. But I made a list back then, and engineering know-how for data scientists, what I wished for was like, okay, know the limits of notebooks, what can be done with notebooks, what are notebooks good for, what isn't don't look good for. There are quite good videos out there. So one notebook from Joel Grass, I don't like notebooks, worth watching, but there was also a reply about from Jeremy Howard, I like notebooks. So if you look one please also look at the other one. You might only like one of those, but to be fair. Then that the development environment isn't the production environment. For a software engineer, it seems like, okay, of course. Not for every data engineer in my experience. Some software design basics are pretty helpful. Modularization, separation of concerns. There's things like methods and classes in this world, even in Python. And you should probably use them. Coding style guidelines, especially naming things. A, B, C, and D are not the best variable names ever. Also untitled 1 and untitled 22 for notebooks might be a thing. Formatting, linter, all the stuff that we as a software engineer know. And things like, you ain't gonna need it, keep it simple, don't repeat yourself, but with a sense of proportion, don't throw it on everything. And last but not least, not last but not least, but one thing also, refactoring. You can refactor stuff. It even works in notebooks, by the way, today. So this is a thing that should be done. And Git. You can version stuff. Those are the basics. I think this is a bare minimum where I say this, everybody working in data should work with this and at least know about this stuff and try to apply those. But maybe let's take a step back. We dive right into it, into the stuff that every software engineer comes to mind if they hear about, what should data learn? From my perspective, so software is mostly about, I get some requirements and I focus on fulfilling those requirements and building the functions needed for these requirements. It's about creation. I know what to build, most likely. I have maybe some product manager who says me what I build, or I have a filled backlog. Maybe I'm doing data-driven product development and get some signal about it. But as a software engineer, I build software and design those and build the architecture. And it's sometimes also experimental, as I said, data-driven product development, but most of the time it's just a create them thing. Data, and now I'm pretty sure your data scientists, well, they are no, with data, it's totally different. We don't know at the start what we're doing. We just do first the experimental phase and trying to get sense into the data, and then we will see what we can actually get out of this. And this is most of the time correct in the beginning. And sometimes it's actually getting the creation as well. So it's also getting software. As I said, you're trying to analyze your data, you get some correlations in your data, and then you start training a model, and then you deploy those model, and those model gets a REST API, and this REST API gets called in an application, and you are in production. Suddenly. So it's also building a creation, so the gap there tightens. And when I talk about data, this means really everything about, from starting with reporting, business intelligence and all this stuff, over to the ML and data science stuff, up to data-driven products, where I build a product which is mainly driven by data and maybe some forecasting service or something like this. But in software, data is most of the time just a byproduct. I think a lot about data modeling in software. What are the tables? What are the relationships between those tables? But the data itself is, I don't care. It's just data. It just happens to be there. It must be used in order the application to work. But I don't care for the content of the data. One example I often use is we once built a search machine for a client for searching, I don't know if it was flights or hotels, I don't care, but it was the usual UI it had. In the upper left corner, there were the boxes where you put in the dates, when do you want to fly, and maybe some extras and filters and so on, and you click search, and then you get all the results with what are the flights and you could take. And we asked the team, hey, what data do you store? We don't store any data, we just get information about the flights, and then we're building a search on it. So what should we store? And they were totally surprised that it would actually be a good idea to store what people are searching for. From a software perspective, it wasn't necessary. I mean, it built a search. Somebody could search for a flight and book it. That there is value in storing what has been searched and what combinations has been searched, what are usual patterns. wasn't the first thing on mind in a software engineer. And I have these shelves here on the slides. Maybe if you're thinking like, so in Sweden it's ICA maybe, and another one is Coop or something like this. From a pure data model perspective, if you take the article catalog from Coop and the article catalog from ICA, they're mostly interchangeable from a data model perspective. Yes, they have some specialties, of course, but I don't care. But the data itself in it, it's completely different. And this is one of the main differences for me if it comes to data. In the data domain, as engineer, as data scientist, then the data itself matters. Yeah? We're coming later to this if we're talking about test environments in data as well. Another thing when thinking about software is, so providing data for maybe analytical cases or for doing ML learning or so is usually not the thing that a domain team and software engineering team says, yeah, that's the thing we want to do, we want to build. Mostly ends up in things like, here's a CSV file dump of what you need. Of course, we can also schedule it as cron, and then you can have it every day. Oh yeah, we have a REST API here. All the other services use this REST API as well. Just use this and get one row after another without ADBC or anything ever. So pretty slow. Or we, come on, screw it, you have a read-only user on the database, have fun. Yeah? But we don't tell you that whenever we change the schema, of course. We just change it, and you have to live with it. So this is the typical patterns we see when applications or teams are asked to say, hey, we should use data. And what is done then is these, by now, ELT processing. I think when I first heard ETL in my informatics career, it was like, okay, ETL is the thing you never want to do because it's ugly. By now it's ELT. The concept is a little bit different by now. We don't extract, transform the data and load it somewhere else, but we just extract the raw data, load it somewhere else and do the transformations there. You might think not a big change at all. I would say it's a huge change because it moves away responsibilities and makes clear abstractions and interfaces between those entities. So from this perspective, in the ELT perspective, there is one way to provide the data, the EL. The data must be somewhere, and then the transformation for analytics is happening in another place. Just to be honest, most of the time ELT also becomes ETLT, so some transformation, we can just easily do it during the extraction and the load. Then it's done, and so it starts that the business logic gets quoted over all places. But why is it so hard to actually provide data? I mean, software engineers aren't lazy guys. Okay, most of the software engineers are lazy guys and building automations, therefore, but it's not like they are stupid. No? So why is it so hard to provide data for analytical purposes? The one thing is the data itself. We have different formats. We have, for instance, different technologies. I mean, there's file formats like Parquet, which as a software engineer, you often don't come around, but are pretty common in the database. You have structural or behavior changes in your source system when you're exporting it. This column was always used to store if the customer was an active customer, but by now we're changing the meaning of this column to if there's an Y instead, there's a number now, not a Boolean flag, and we're storing now since when is this customer with us. We just changed it. Nobody notified downstreams. We get late data, stale data, data gets updated within the process in the application. The updated data isn't sent to analytics. We have historical data. We have all the privacy concerns. We cannot push out every data in a pure way to the analytical places. This is the complications we have on the data side. Then we have the implementation, all the tech stuff. As I said, unknown technologies, Parquet, a lot of Python in the ecosystem, maybe a lot of Java-related technologies on the other side. It's often treated as a simple one-off glue script. Just come on, we let the dump run every night. No testing, no monitoring. Nobody knows when it fails. The first one who notices that it fails is the one user in the end of the dashboard who sees that the data didn't update, and then it cascades all the way back to find the failure. No data validation. Often focus on quick wins because it's never priority. Providing data is most of the time not priority within the teams. Or the other way around, we often see very, very complicated solutions. So this is all reasonable. But I think the most important part is missing awareness and communication. As so often, it's most of the time not tech. But for what we see is that most of the teams that building software don't even know that their data is used somewhere else and for what is used somewhere else. They don't even think about, or there's no way they could think about, hey, if I change this column name, it breaks other systems, because they don't know that it's used, that anybody has direct access to their database. It was given like 5 years ago, the team is totally different by now. Nobody knows that anybody has direct access to this database. And as a software engineer, it's unthinkable. Of course, we don't expose our database. We always have REST APIs or some clear interfaces for them. So there's the missing awareness, and even if there's awareness, communicating changes, even especially breaking changes, is pretty hard. One thing, I mean, we are still software engineers. That might be an obvious non-technical issue. What are we doing? We find technical solutions. The one thing which gets a lot of traction right now is so-called data contracts. You can think of it like an API spec, but for data. It describes the schema, it describes the fields, the names, and so on of the data you provide. The data could be a file in an S3 bucket, it could be an API, it could be a table or a view. But it not only describes the technical aspects of the data, it describes also the usage of the data, what is it used, for what can it be used, for what shouldn't it be used. Maybe there's something like, hey, this can be used for analytical purposes, but it's not updated and it's not 100% correct because reasons X, Y, Z, so please don't use it for accounting or billing, maybe. Or you can even negotiate something like, okay, this contract is valid now for 1 year. And we might consider changing this after 1 year. So the main thing about this is people talk about it, getting awareness and doing things together. A data contract, how does it look like? It's YAML, as so often these days. So defined as a YAML, you see here at the top, we have those servers defined. In this case, it's an S3 bucket, so servers is more like some infrastructure where data resides. We have some terms here, can be used for reports, analytics, and machine learning usage, and something else, limitations, maybe some billing. If you use this, you have to pay this and this. This is more informational part. And we have the model here. As it's a YAML, it can be validated. So what can be done is you can define this contract, and if you're publishing data, you can actually check, hey, the data that I published, does it fit to the contract? I mean, there's CLIs for this right now that you can just execute in your CI/CD process and validate if those contract is still valid. So, and as I said, it's not only the way getting from the application to the data, but it's getting back. Aggregated data, refined data is getting back to the application so that the users of applications can do reporting and can do analytics, or even from data there comes some model which is hosted or should be deployed at some point. Now, so what is the main message here? Software engineers need to include data also into architecture and design considerations. And I think for a long time this didn't happen. It starts happening now, and I want you really to incentivize. Think about data. Where is your data used? To whom do you provide data in the end? Who is your users in the end? So now I tricked you into this talk with, hey, what can data and ML learn from software engineering? And I'm now telling you that what you as a software engineer can learn. But we can also, from a data perspective, really learn from software engineering. one thing that struck me is know the structure and the user, and know and structure the user and the domain. Really understand what is going on, what processes are being done in this thing, and structure your technical solution according to it. I mean, most likely a lot of people from you are familiar with things like domain-driven design, where you think about, hey, what concepts do we have, what aggregates do we have? You have methods like event storming or something like this. I've actually never seen this done in the data space. You're just starting with a script and then expanding the script and then structuring it a bit. This is the way it does. But thinking about the business and the domain sometimes happens when you design the data model, but mostly never when you design the process of getting data out, storing it somewhere. Only the data model itself is sometimes used. Then another thing, testing. I have written more testing, should actually have said start testing at all. So we can do at compile time, unit test, integration test, all the stuff that is done in software engineering as well. A little bit special in data are, I would say, data tests at runtime, because you can do a lot of stuff at compile or build or CI/CD time, but what you can't do is you can't test the data you have. And as I said in the beginning, from a data engineering standpoint, the data itself is important. You want to test, is the data I got from whatever system really the data I expect it to be? So I would do at runtime tests as well, those data tests. So unit test covers only logic, but in the end we have the difficulties in data engineering that it's often glue work. We have a lot of interfaces. There's no point in mocking those interfaces. Then the test, yeah, the logic is okay, but everything else not. So creating test data is most of the time a lot of effort. It's getting better now because I'm not a really huge Gen AI fan, to be honest, but generating test data is great with AI. Use it really often. So mocking is only partially helpful, as I said. But you can also do integration tests, and this is getting pretty common. Using really integration tests in your CI/CD pipeline on real data. It doesn't have to be all real data, depending on how much data you have. It could be a substract. But this should be really done. And the data test should be done early. Maybe you write a pipeline that gets data somewhere, does some wrangling, some analytics, and some aggregation, stores it somewhere else. Test the data you got early at the beginning. And I had these in the beginning that, maybe dev and prod is not the same, and this happens quite often, to be honest, in data. So testing in prod, because only in prod is all the data, so where else should I test? And this brings me to staging environments in data. So the left side is pretty common. We have some dev environment, we have a pre-prod, QA, whatever you name it, environment, we have a production environment. And now the data team comes up and we need some stages as well, and we need the data in the stages. And then the software architecture or whatever enterprise architect says, hey, no problem, we're just doing this like this. In dev, you get the dev data. In pre-prod, you get the pre-prod data. And in prod, you get the prod data. And you know what you have in dev. Yeah? Every user is the same name. Most of the time, it's AAAAA or BBB or whatever, where you just let your cat run over your keypad. So it's most of the time rubbish. So what you most of the time need actually is like this. So you need the production data actually everywhere. And I think everybody of you sees the challenges. I mean, either duplicate data or doing some views or virtualization on this. This is the technical aspect. Then there might be all the privacy issues you have. Most likely you can't have all the production data in a pre-prod or dev environment, so makes it pretty complicated. And when you're developing a feature that is both in the application and on the data side, you basically need both of this. So you need the feature that is deployed to dev, also the data producing that is in dev. So you end up with this kind of theme. And to make it even more complicated, to be honest, most of the time in data, you can even distribute between data engineer, who is providing the data for all this stuff, and the data scientist. And as you might have thought, it's all the same. So don't say replicate all the data. I mean, the solution is obviously not just replicate all the data and copy it multiple times and store it multiple times, but be aware that when you're doing providing data and building stages for data, be aware that you have to manage those data things in some way. Most of the time it's views on this, it's anonymization scripts for the privacy concerns, which is done. I'm doing a lot of stuff with Databricks where you can actually share your catalogs or the data catalogs and for the environment to multiple places as a read-only thing, but stored only once. These are the solutions we are seeing in this field. Then coming to continuous integration, continuous deployment, testing, a thing that should be done. This is shouldn't be too unfamiliar. It's just CI, CD, and then you're deploying something. The special part is especially if you're doing machine learning, you're doing continuous training as well. So training your model with the new data, with the new code, testing this again, and deploy it afterwards. This is a thing that maybe should be learned. Another thing, I think here is quite some monitoring and open telemetry talks as well this week. Monitoring your stuff. In this case, it's not monitoring the code, the application. In this case, it's monitoring the data, which would be really helpful. So do tests on your data. Show those tests. See what runtimes have those pipelines you have and those aggregations. Visualize it. Monitor it. Do alerting on it. It's possible. There's tools for this. And it's even not just click, click, click tools. It's really like coding tools. So now we're coming to the modern data stack that emerged out of this. Just one example. So modern data stack is pretty loosely defined. You find common definitions of it, but it's basically SaaS, cloud data warehouse, the best of breed tool set to do this, and doing this in a software engineering style, I would say. And one thing is, for instance, dbt, it's called. And dbt, it's a data tool which allows you to define all your transformations in a SQL format. This is SQL with common table expressions. Yeah, there's some templates in here with those curly braces, but you define SQL code. You can define, in addition, some config in a YAML file. Have it all in a repository, bundled together, and you can write tests on it. For instance, here we have, for the customer ID, we expect it to be unique and not null. Pretty basic tests. You can write whatever complex tests you might have. There's also standard tests for I expect that the values in those columns distribute in a particular fashion, something like this. You can test this. You can do unit tests as well. So for instance, we have this model. Model in this case is a table as defined before. And given we have some table with the following rows as input and another table with those rows as input, we expect that this is the result that is stored in the table. So you can actually do unit testing on your SQL code, on your pipelines, on your data pipelines. So really the engineering best practices. What dbt also gives you is kind of a documentation and lineage. So we have raw tables coming in from the EL process, doing some staging tables where we prepare data and then doing analytical tables that are actually useful for the end user. And we can visualize those flow in a data pipeline. And it also creates some documentation out of it. So which columns do we have, a description of it. It's all generated from the SQL and the YAML files you have. So and this is all stored in a Git repository. You can deploy it however you want as a Docker container. You can do CI/CD on it. You can even compare branches with each other. You can say, hey, if I now run this script here from the branch, how would the data change if I now merge this into the main branch? What rows would be changed? What columns would be changed? What would the changes look like? That's pretty cool. Another thing to learn is documentation. I think in software engineering there are quite some things where documentation works pretty good for me, especially, is this thing called architecture decision records. A pretty nice thing, so where you document really your important architectural decisions. In this case, for instance, we have this use case and this concern, and we decided for this to achieve whatever, accepting. So you really make it transparent. There's this one template. There are a lot of templates for architecture decision records. In my opinion, a really good thing to use, and makes absolutely sense to apply it in data as well. So there's most of the things I would say that data could learn from software evolve around quality. Testing, staging environments, documentation, clearly defined process of getting in production. Those are the things that are really important to learn, besides the basic with coding. But there's one more thing to actually keep in mind. The one thing is, this is a survey done by the company behind DBT, so the data company. And they were asking how many people in the organization are responsible for data infrastructure. On the x-axis below, you see the company size. And here you see how many people are responsible. And you see even for companies up to 1,000 people, it's a maximum of 10 people responsible for data stuff. And now if you think about maybe a software engineering company with 1,000 people, how many people would you expect to be in software engineering? And what I see is the data teams are most of the time way smaller than the software teams. And applying all these software engineer best practices, they have their value, definitely, but they also come with a cost and some effort that has to be put in. And it actually needs people to do this. And at some points, this is the same for data analytics, same picture. We need those people in data as well. And given the recent macroeconomic environment, most people also said either no change or somewhat negatively impacted, but most of the teams don't grow. So it's not that we see like a lot of people getting into data, or data teams are getting more people to actually solve and work on those issues. So this is maybe a thing to keep in mind. Yes, learn from software engineering, but also be aware of the manpower might be way smaller. So don't take the same ideas, take the same, compare them completely the same. So, what to take away? I think I'm pretty good in my time. Yep. So what data can learn, some of the basics I learned in the beginning, then the focus on quality, the focus on automation and documentation. I think this is the most important part. But also, what can software engineering learn? Treat data as a useful information, something that has value, that has to be provided. And these being data-driven is actually a really helpful thing. So a lot of teams we enable that we want to say, hey, this data is useful information is most of the time, maybe you use your data that you collect to understand the users of your product better. What are they actually doing with your application? And most of the time you can see it from the data that is stored within your application if you're looking onto this maybe from an analytical perspective. Most of the time, just dumping the files once to an analytical database, maybe DuckDB or something like this for a lean approach, and working on this as well. So, yeah, data can learn. There are some differences. It's tooling and technology. Yeah, that's from my side. Thank you. If there are any questions, I'm happy to answer them. Otherwise, I will be here as well. Please. This was mainly an example for a good thing on how software engineering does documentation in a good way. And architecture decision records are, in my opinion, a good idea to do this, and a pretty good example. Of course, using architecture decision records in data is when you are doing architectural decisions in your data space. Document them like this, for instance. There are multiple other ways to document stuff, and that should be documented. The architectural decision records were just an example on what to do, maybe.